So essentially, Tableau has two tool sets. One is the actual database engine, and that database engine is called Tableau Hyper. And then they have a tool to interact with the Tableau Hyper, and also it's called a visual tool. So we're going to that no-code approach. So you can either access the Tableau Hyper uh, in-memory database. In fact, they don't even call it a database. They call it Tableau Hyper in-memory storage, to keep it very generic. So that's what they're calling it. So the Tableau Hyper storage system can be interacted with APIs they have provided, or you can connect using the no-code solution, which is a Tableau Prep. The APIs and writing code with API, that is of no cost. The SDK is part of the Hyper package, but the Tableau Prep is a separate software similar to the Tableau desktop software that you have to purchase a license to use. Okay, now let's go ahead and kind of take a look at the high level. Let me move this icon. So when we look at the high level product line, you can see we have the Tableau Desktop, Tableau Web, Tableau Server, Tableau Online, and Tableau Public. The Tableau Public is a free version, just like YouTube, where you can upload your visualization for free, but unfortunately it's open to public. Now the Tableau Online is the cloud version of the Tableau Server. And of course, the desktop and web, those are the development tools for building the visualization. One is the Tableau Web is kind of a lightweight version, does not have a lot of features. And the Tableau Desktop is the full high-powered version. So that's only used for visualization. Now the Tableau Prep is also a desktop-based application. So just similar to Tableau Desktop, Tableau Prep runs on your local computer. It's not a web-based interface yet. So at this time, the release is a desktop application. Okay. Now, when we look at the visual ETL, let's call it that. It's a visual no-code ETL tool. And then in memory, that is your Hyper database, and then the visualization. The icon for the Hyper is kind of confusing. One of the icons is on top of the Tableau icon. They have two green database type icons. That seem to be one of the icons for Hyper. Another icon is that one right there on the top where you have the different stripes. So I'm going to explain why they have that specific design for the Hyper. So we're going to the next screen and we can take a look at that. Okay, so the Hyper database engine, right? The Hyper data engine, they striped it like this at different levels. So you can see the extract creation, extract refresh, and a federation, and then going right into dashboards and deep analytics. And they kind of highlight those different colors based on the functionality, such as dashboard interactive analysis and deep analytics for heavy processing. Now let's go ahead and take a look at another visualization here. This is the kind of Hyper architecture. So now we're going to drill into what is the Hyper architecture. So a traditional database at the top, you can see has the ETL process, start with an OLTP, OLAP, going right into key value pair, data mining, Hadoop, graph databases. So that's kind of your trajectory for where the database is going, where the data warehouse industry is going. Now, what Hyper has done is taken advantage of the memory and have created something more, instead of a horizontal, they've created kind of a vertical integration. So you can see how they have the transaction OLTP, analytics, and beyond relational database all kind of blended into one data store, and that's what they're calling Hyper. Now, looking at some of the technical aspects of this, what makes Hyper faster and more effective? Some of the components are borrowed from columnar database, compression, and also the table representation is more in data blocks, similar to Hadoop, HDFS, or Spark. So it's kind of borrowed some of the best practices from relational database and MapReduce, and kind of combined them all together and removed some of the complexity of that implementation by putting it in memory, and then organized it in a very monolithic fashion, very modular fashion. And I'll show you the advantage of that. We'll see a case study from Netflix where they've used this architecture to process their recommendation engine. And that is a huge leap for Hyper, because Netflix has a huge volume of data, 60 petabytes of data, and they're using Hyper. Okay, saying that, the Hyper is based on SQL. That's a bigger advantage compared to the Hadoop scripting, which was based on its own something called PIG Latin scripting. So having a native SQL parser and having this concept of tables just makes it easier for a SQL database developer to quickly adapt to Hyper. Okay, so now we'll go ahead and dig deeper into the actual API and implementation of Hyper, and we're going to take a look at how that all works in cohesive fashion. So the Hyper API, there is a Hyper API for Python. Unfortunately, it only works with Python 3.6 64-bit. So make sure you have something 3.6x or 7, preferred 3.7 with a 64-bit operating system. Also, the API is supported in C++ version 11, or you can use the CLang version 7 or anything in that range. But you have to be careful with the versions, because if you use a previous version, this API will not work. So you have to make sure you look at their training documentation and their samples to have the right environment. One of the recommendations is to set up virtual environments and just install the Hyper API in that virtual environment with that specific version of the core programming language. So the Java SDK is 1.8. and the .NET Core is 2.2. So all these are very specific. If you have a newer version, you would have to make sure you set up a virtual environment to have that specific version work with Hyper. And that's been a challenge, because a lot of environments have the latest versions or maybe an older version, and it just causes conflict. So make sure you have a virtual environment and follow the exact version to the second level. So if it says CLang 7.1.4, make sure you're right at that 1.4. 1.5 may break something. It's just you have to be very specific with your versions. Okay, so looking at the Tableau Hyper API, now when we look at the Tableau Hyper API, we're looking at heavy code. There's heavy code, low code, and no code. So we're going to start with the heavy code, look at low code, and then go into no code, and end this webinar with the no code. Okay, so we're looking at heavy code at this point. So these are all the APIs that is used to interact with Hyper. And I'm going to go through some of these APIs in detail in the next slide. Okay, so what we're going to look at is we're going to start looking at the very basics of how to create a database using Hyper and how to push the data into it. Okay, so like I mentioned, Hyper is kind of treated like a database. So when you want to go ahead and create a data store inside of Hyper, they call it create a database. So you're creating a database, and that database essentially called mydatabase.hyper. That's the physical file name. And that particular database that you just created on your local file system is going to be loaded into memory, and all the computation and processing and everything else gets done in memory. So you create a database and you push the data into that database. Very similar to other database programming language. So you can see we're using the Python API, and I will go ahead and walk you through each one of these steps, how it's done. But just I wanted to show you how easy it is to create a database, create the table structure, and insert the data. So if you look at the bottom right, how to run a query, you can run your select statements within a with clause. And you can also go ahead and extract and append data from multiple databases. In this case, we'll call it hyper databases. You can take different hyper tables and append them together. And those come in handy when you have a large volume of data and you want to keep accumulating it every day. You're getting millions of rows of data and you do some processing and you aggregate it. And every time new data comes in, you want to go ahead and keep appending. So those are functions that can be done using Hyper. Again, that's part of any ETL tool, appending or truncate and load. Okay, so now let's go dig deeper into this API. The first step, there are 7 steps. The first step is to import the Hyper API library, and that's what you're doing there is downloading it. It's on that link in that website, in that slide. You can download the API. It's on GitHub, and you can download it for any of the versions I mentioned: Java, Hyper, CLang, or .NET. Okay. Now we are going to look at starting the Hyper process. Now that step 2, starting the Hyper process, that's where you actually kick off and run that process that takes that Hyper file and puts it into in-memory. And from that point on, your system's RAM is being utilized to process and do all kinds of functions within the Hyper environment. Now you're opening up the connection to the Hyper file, which gets uploaded right into the RAM. You define the tables, you create the tables, and you add data to the tables, and then you close your connection. Very straightforward. And the reason why it's this straightforward is because it's designed for decentralized deployment, serverless decentralized deployment. So for instance, if you wanted to put this on a Docker and you wanted to have 20 or 30 of this running in the cloud in AWS and processing different types of data, you can do that. And it can run, it can finish its process, it can shut down. It can run, it can finish its process and shut down. So it's very, very monolithic in its approach. It doesn't have all these extra processes and components running. It just puts everything in the RAM, trusts the RAM to do the job. So it kind of works in that small chunks up in the RAM. So it's kind of that concept of centralized versus distributed to decentralized. So Hyper is kind of a form of decentralized ETL. Okay. So now you looked at something that was, I would say, heavy code. This requires a lot of coding and understanding of logic. And again, if your ETL process requires complexity in pre-processing, this is a good place to have a heavy code approach. Now, moving towards a low-code approach is using another library on top of the Python Hyper API. Is that library could be leveraging a much easier framework called Pandas, which is sitting on top of Python, but it's a very simplified way to load Excel files, CSV files, process them, truncate them, and load them into a database. So Pandas is a kind of very lightweight ETL tool that sits on top of Python. And what this particular open source project, PanTab, has done is they've taken the Hyper API, and instead of writing all these codes, they've abstracted it out. They've given you very simple 3 lines of code to load a CSV data into Hyper without having to write all those extra functions in between. And they call it frame to Hyper, frame from Hyper. And so you can either take data from Hyper or put data into Hyper. Now the word frame is very specific to Pandas. So if you were familiar with the Pandas Python library, the concept of frame is just, it's kind of a data structure terminology in Pandas. So frame to Hyper, frame to frame from Hyper, and it's a very straightforward syntax. As you can see here, you're just importing the Pandas and you're importing the Hyper API, and all you have to do is load a data frame, load your CSV file into the data frame, and then you can just say frame to Hyper, call that data frame that you just loaded, and then you can just give it the name where you want to store that Hyper, and you just give it a table name, and then you're done. So and then you just save it once you're done with that. So this is, again, a kind of a low-code solution to doing the Hyper API implementation. So we looked at 2 ways of doing this. Now let's go ahead and take a deeper look at how some of the case studies work, and then we're going to go right into the data prep low-code approach. So here's an example that Tableau provided, which here is an hospital using Pandas, which is the Python library you just saw, CSV file, and loading that into the Hyper. And from Hyper, they're loading it directly into the Tableau and running it from there. Okay. Now, this pipeline right here has a little bit of complexity that they're not explaining, and some of those complexities are, how does the data come from the SlickBay to CSV? So from that application, how does it get into CSV? That's a different process that loads it to a CSV file and then pushes it to a common location where Python Pandas can read it and then create the Hyper. So you're not seeing all the connections, the lines between them. And once you've created these Hyper files, right? These are data structures. Once you've created these data store and data structures, how do you get it to Tableau Desktop? If it's Tableau Desktop, that you can just open up Tableau and say data source and just click on that Hyper and it'll load it into Tableau for you. But if it's a Tableau server and it's something that needs to happen on a regular basis, then you would have to use another API from Tableau for the Tableau server API. Using that Tableau server API, you can go ahead and take the content, load it, publish it into this Tableau server. So that's publishing the Hyper data store into the Tableau server. That requires the Tableau server API to do that. So in this webinar, we're just focusing on creating the Hyper files. But again, if you were to go ahead and have an end-to-end pipeline, you would need to also learn the Tableau server API so you can push that to the Tableau server. Okay. So here's another example, and this is one of the classic examples. What brought Tableau and Data Prep and Hyper in the limelight was the idea of taking 60 terabytes of Netflix data, running it into a container, and then each container has your Tableau Hyper API code that runs in memory, creates these separate extract files, and then using the Data Prep, which is a low-code solution, to aggregate these data Hyper queries and publish it into a Tableau server. So now instead of having to learn the Tableau server API and trying to manually write that publishing into the Tableau server, you can do this entire process end to end from the left all the way to the right using the Tableau Prep ETL tool. Visual, let's call it the visual Tableau Prep ETL tool. And one of the advantages of using the Tableau Prep is you can do the scheduling on what time do you want it to run. Based on some event, you can kick off that schedule and you can let it run. Now Tableau, so I'm going to bring up the Tableau Prep now, kind of quickly show you how that ETL tool looks. Okay, so let's go ahead and take a look at the Tableau Prep. So give me 1 second. Okay, so here is your Tableau Prep screen. So when you launch Tableau Prep, it's very similar to your launching Tableau Desktop. This is called Tableau Prep. So you can see the Tableau Desktop and Tableau Prep. They have this, similar type of icon, and it's called Tableau Prep Builder. That's what they call it, Tableau Prep Builder. Okay, looking at the Tableau Prep Builder, once you launch it, it brings up a screen like this. Each of your ETL is called a flow. So you can create different flows for your data source. So for instance, let me show you a flow here. Here's a very simple flow. First, you choose your connection. Are you going to connect to a database similar to your Tableau desktop? You can connect to any data source. Now, as you connect to your multiple data sources, you bring that in, and then you would start creating the different flows. So if I wanted to bring in a data here, like forecast data, and then I click the plus, there is something called aggregate, pivot, join, union, and then there is a script and output. So they kind of simplified the whole ETL process. So you can just kind of choose from this 7 or 8 categories. Now, most of the integration is usually join or union, and some aggregates. But let's say you wanted to do some heavy lifting, running some script. So you can do that as well. You can go ahead and click on script. And there are 2 types of scripts you can write. You can write an R script, or you can write a Python script. So you can do your R or Python scripting, and that can run, maybe you're running a regular expression or some complex machine learning computation from TensorFlow. You can have the Python API connect to TensorFlow, provide some sentiment analysis that you can bake into the system. So that's how the PyTab server works. Again, that's another component, the Tableau Python PyServer, which has to be installed on the Tableau server, and you'd have to configure it in a way that you can access that particular API to push the Python scripts. Think of it like a small Node.js in between your data prep and the Tableau server. Okay, so one of the things I want to cover is the visual ETL. One of the concepts of visual ETL is to really know, how does my data look? What is my distribution? What are my maximum counts? So here it gives you a very nice way to quickly see the data itself. So you can actually see small graphs of your data, and you can move down like that, and it kind of will give you an idea of the frequency. So this is a very good way to quickly see, what's happening in my data at this stage. How have I reduced it, or how have I aggregated it? So it's a really good way to look at counts, group bys, and sums in a visual way while you're doing your ETL. So while you're doing your ETL, you can click, and quickly it'll tell you what's happening in the system. And you can look at data samples, and you can look at any changes, and you can look at settings. So it's very visually done. The top is your visual graph, and then the bottom gives you details of the visual graph. So as I click on my data source, you can see years of rows. And as soon as I click on that, it'll tell me the results from that ETL job. And also it's going to provide kind of a graph So quickly I can see, oh, I have some nulls. Let me click on the nulls and figure out which ones are my nulls. So you can essentially do data exploration and discovery, and at the same time do ETL. And that's the power of data prep, is you don't have to have that hard code coding skills or SQL skills to analyze your data. This makes it much easier to analyze your data with just drag and drop and click. And in the background, it just generates the code for you. It creates the code to run the hyper. So you're essentially creating that framework. Okay, so that is your introduction to Flow. Very straightforward. As you can see, there's not much here. All you can do is pull in your connections. Once you pull in your connections, set up your joins, and at the very end, you create your extract. So what happens is when you create your extract, you can do two things. One is you can generate a hyper file. You can see you can generate a hyper file and put it in a specific location, and then have it published out to the desktop server. That's the beauty of it. You don't have to have the server API. This flow will automatically publish it out to your server for your users. So you can schedule it and have it published automatically. And that's huge when it comes to cron jobs and maintaining a schedule. If you have a lot of different extracts you're working on, Tableau Prep is a great way to manage it. So once you're done with all this, you can publish this Tableau Prep to the server. So essentially all your flows would be running from the server. Just like you would be running a Tableau workbook, you would be running the Tableau flow. Okay, so saying that kind of concludes our introduction to the Tableau big data store kind of framework. And again, Tableau is going through changes, naming changes, and architecture changes based on their integration with Salesforce. But this gives you kind of a high-level picture of where we are and how all this fits together. So now I'm going to open up for questions.